Have you ever wondered how we measure things that are far too small to see or distances so vast they stretch across the universe? Our world is filled with extremes, from the tiniest particles to the largest cosmic structures. To make sense of it all, scientists have developed a variety of measurement units, each tailored to a specific scale. In this video, we'll journey from the microscopic world of atoms to the unimaginable distances between galaxies, discovering how these units help us understand our universe. Start small, really small. The millimeter is a familiar unit, but did you know it can be divided into 1,000 even tinier parts called micrometers? A single human hair is about 100 micrometers thick, and most cells are just 10 to 30 micrometers across. These tiny measurements allow scientists to study the building blocks of life and matter, revealing a world that's invisible to the naked eye. But the microscopic world doesn't stop at micrometers. Enter the nanometer, a unit so small it measures things like viruses and strands of DNA. For example, the famous double helix of DNA is just 2 nanometers wide. At this scale, scientists can explore the very instructions of life and the tiniest machines that make up living organisms. If we zoom in even further, we reach the scale of atoms. Here, the angstrom is the unit of choice. Atoms are incredibly small. Take hydrogen, for example. Its radius is about 0.5 angstroms. This scale is essential for chemists and physicists who study how atoms bond and interact, forming the foundation of all matter. At the very edge of smallness, we find the Fermi, a unit used to measure atomic nuclei. A single proton, for instance, is about 1.6 Fermis across. This scale is crucial for nuclear physicists who study the forces and particles that make up the heart of every atom. It's a realm where the rules of physics become truly strange and fascinating. Now let's leap from the tiniest scales to the largest. Our universe is unimaginably vast, and measuring these distances requires entirely different units. The astronomical unit, or AU, is used to describe distances within our solar system. For example, Earth is exactly 1 AU from the Sun, which equals about 150 million kilometers. When we look beyond our solar system, we need even bigger units. The light year measures the distance light travels in a year, about 9.46 trillion kilometers. It's a handy way to describe the vast stretches between stars. For instance, Proxima Centauri, our nearest stellar neighbor, is 4.24 light-years away. Astronomers often use another unit called the parsec. 1 parsec equals about 3.26 light-years. This unit is especially useful for mapping the positions of stars and galaxies. It helps astronomers describe distances on a cosmic scale, making it easier to compare the vastness of space. Let's put these units into perspective. The Milky Way galaxy, our cosmic home, is about 100,000 light-years across. That's a distance so immense it's almost impossible to imagine. Using light-years and parsecs allows scientists to describe and study the structure of galaxies and the universe itself. But the universe doesn't stop at our galaxy. The observable universe, the part we can see, is about 93 billion light-years in diameter. This number is so large it challenges our imagination, yet with the right units, astronomers can map and study even these mind-boggling distances. You might wonder why we use so many different units. The answer is convenience. Imagine writing out 150 billion meters every time you talk about the distance from Earth to the Sun. It's much easier and clearer to say 150 million kilometers or 1 AU. These units make communication and understanding much simpler. Using the right unit also gives context. Saying the Sun is 1 AU away immediately tells us we're talking about distances within our solar system. It helps scientists and the public alike to quickly grasp the scale being discussed, whether it's the width of a cell or the span of a galaxy. Understanding these scales isn't just about numbers, it's about perspective. From the quantum world inside our bodies to the cosmic expanse that surrounds us, measurement units help us find our place in the universe. They connect the smallest particles to the largest structures, showing us the incredible range of existence. As science advances, our need for precise measurement grows. New discoveries often require new units or adaptations of old ones. Whether we're probing the heart of an atom or mapping distant galaxies, the right unit makes all the difference. It's a testament to human curiosity and ingenuity. In the end, measurement units are more than just numbers, they're tools that help us explore, understand, and appreciate the universe. From the tiniest Fermi to the vastness of light years, each unit tells a story about our quest to measure the unmeasurable. Thanks to these scales, we can journey from atoms to galaxies, all within the span of a single thought.